Yeah. So let's move on to this next topic in permutations and combinations, which is identical things. If out of n things, p are exactly alike of one kind, q are exactly alike of the second kind, r exactly are alike of the third kind, and the rest are different, then the number of permutations are given as n factorial by p factorial by q factorial by r factorial. Okay, so I'll explain this with an example. In how many ways can the letters of the word banana be arranged such that all letters are considered? So if you remember, we did a word garden in the previous practice questions. Garden. What you notice here is all these 6 letters G, A, R, D, E and N are different. So we had 6 different letters, and the number of ways to arrange these 6 letters when all of them were taken was 6 factorial. What has changed here is that in banana we have only 3 distinct letters, which is B, N and A. See, B occurs once, A occurs 3 times. I have A here and A here, and N occurs twice. So in this case the answer will not be 6 factorial. The answer in this case will be 6 factorial divided by 2 factorial into 3 factorial. Why 2 factorial? Because here we had 2 n's. I have 2 n's and I have here 3 a's. So that is why 2 factorial multiplied by 3 factorial, and I have only one b, so that will not figure out. Only if a letter or a digit is more than once we write here. So here n was what? 6. This is n, and p factorial is 2 factorial, q factorial is 3 factorial. So the answer here would be 6 into 5 into 4 divided by 2 factorial. I've just cancelled out 3 factorial because I'll have 3 factorial here and 3 factorial here. So this will basically cancel out. So what does this give me? 60 words. Whereas if I had a 6-letter word garden and all the letters were different, I had how many words? 720 words. 6 factorial is 720, and here I just have 60 words. So the number of words have decreased. Now you notice here, if you are wondering why, I'll just give you a little example here. Let's say I had A, B and A, and I had A, B and C. This we've discussed before, that the number of words were 3 factorial or 6. Now let's try and find the number of words that can be formed here. I can have A first, then A and B. This is the first word. The second word would be A, B and A. The third word could be B, A and A. Now there is no other word that can be formed. There is no other permutation possible. Why is that so? Because I had 2 A's. In this A, B, if I select the second A first and the first A afterwards, again I'll have A and B. It will not make a difference if, for example, this is A1 and this is A2, and I make A2 here and then I write A1 here. A2 A1B or A1 A2B is one and the same thing because they are basically A's. So that is why here I had 6 words when I had A, B and C. Here I'll have how many? Going by this formula, I'll have 3 factorial divided by 2 factorial, which is nothing but 3 words, and we've counted these 3 words here. So this is the same thing we have done here. I have 6 factorial divided by 2 factorial divided by 3 factorial. So whenever you have identical things, the number of arrangements reduce. We'll do some more questions on this. So let's consider this another question on identical things. The word is hallucination. Find the number of arrangements all the letters can be arranged such that there is no restriction. So when there is no restriction means I have to take all letters and I have to just rearrange them. So let's count the number of letters. I have H here, which occurs just once. I have A, which occurs twice. I have L, which occurs again twice. Then U, C, I, N, T and O. So I've just written the number of times each letter appears in the word hallucination. So if we count the total number of letters, all these add up to 13 letters. So in the numerator I will have 13 factorial. Now since A occurs twice, so I'll divide by 2 factorial. Then again L occurs twice, so I'll divide by 2 factorial again. And then I have I, which occurs twice, so I again divide by 2 factorial. And N, which occurs twice, so I again divide by 2 factorial. So this is the answer to the first part. I have 4 letters which come twice, these 4 letters A, L, I and N, that is why 2 factorial occurs 4 times. So this is the answer for the first part. Now all consonants are together. As I discussed earlier, whenever we have to consider some things together, what we do is, like here I have to take all the consonants together, I combine them and treat them as a single entity. So I have the consonants here H, I have L, I have C, I have N and I have T. Okay, now this is L, which occurs twice, and I have N, which again occurs 2 times. So I will consider this entire thing as okay. So let's take this second thing now, the second part. So I need all consonants to be together. So whenever I have to consider that all consonants are together, what I do is I will write down all the consonants and take this as one entity. So I have H, L, N, C and T. L occurs twice and also N occurs twice. So these are all the consonants in the word hallucination. So now I will consider all these as one entity. So this is one letter for me. And what are the rest of the letters? I have 2 A's, I have 1 U, I have 2 I's and I have 1 O. So how many letters do I have now? This is 1, 2, 3, 4, 5, 6 and 7. So I'll write here 7 factorial divided by A occurs twice, so divided by 2 factorial, and then I occurs twice, so I again divide by 2 factorial. Now these 7 letters here, the consonants, I have 7 consonants, these 7 can also arrange among themselves. Here in 7 factorial I have considered them as 1, but actually they are 7 and they can be arranged among themselves in how many ways? Again applying the same formula, by 7 factorial divided by 2 factorial because they are 2 L's, and again by 2 factorial because they are 2 N's. Okay, so I multiply this. So this is the final answer for the second part. What does this first part mean? This is the arrangement when I considered all the consonants as one entity. Okay, consonant as one entity. So this takes care of the part that all the consonants will occur together always. and this part here, the second part, this arranges the consonants among themselves. Okay, so this arranges the consonants in that one entity which I have considered here. These are the number of ways in which the consonants arrange among themselves. This part ensures that they remain together. Let's yeah. So now we move on to the next part, which is the third part. Here what is given is the vowels should occupy only the odd places. So again, these are the number of letters, and these are the corresponding letters as in the previous case. Now I have drawn here 13 dashes because the word hallucination has 13 letters. So this is the first space, the second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11, 12 and 13. Now what are the odd places here? This first one, the third one, similarly the fifth one, 7, 9, 11 and 13. So the vowels can only occur at the starred places here, the places where I have marked a star. Let's count the number of vowels first. I have 2 A's, I have 1 U, I have 2 I's and I have 1 O. So in all I have 6 vowels, but the number of odd places I have is 7. I have 7 odd places, as you can see, the places which are marked with star. So if I have to place 6 vowels in these 7 places, first I have to choose what are the places I want to place vowels in. So out of the 7 places, I'll have to choose 6 places where I will place the vowels. So that can be done in how many ways? 7, C, 6. Okay. So 7, C, 6 the number of ways I choose 6 places out of these 7, and in these 6 places the vowels will be placed. Now once I've selected these 6 places, the vowels can arrange themselves in the 6 places in how many ways? 6 factorial divided by 2 factorial multiplied by 2 factorial here. This 2 factorial is because I have 2 A's. This 2 factorial is because I have 2 I's, and 6 factorial is because the total number of vowels is 6. So up till now I have, through this formula, chosen the places in which vowels will be placed, and I've also arranged them. So 6 places are already done with. Now we have 13 minus 6, 7 places. In these 7 places the consonants will figure out. Okay, so in how many ways can consonants be arranged? I'll have 7 factorial divided by, I have L here occurring twice and I have N here occurring twice. Everything else occurs just once. So this can be done in 7 factorial divided by 2 factorial into 2 factorial here, as we did in the previous case. So these are the ways in which consonants are arranged among themselves. So what is my final answer here for this question? It would be the number of ways in which the vowels arrange themselves, that is 7c6 into 6 factorial divided by 2 factorial into 2 factorial multiplied by 7 factorial divided by 2 factorial into 2 factorial, in which the consonants can place themselves. So if you are clear with this question, I think you are through with most of the questions on identical things. Okay, so let's take some more practice questions now. Question number 1. Find the number of 4-digit numbers that can be formed such that no 2 digits are same. So I write 1 here and I make 4 dashes. Number of 4-digit numbers such that no 2 digits are same. As I have discussed before, this place can be filled by 9 ways. Why? Because I can have any number from 1 till 9. I cannot have 0 here, because if it becomes 0, then it's a 3-digit number. Now one of the digits has already been used up here. This space has already been filled. So this second space can be filled up in 10 minus 1, again 9 ways. Why 10 here? Because in the hundreds place 0 can also figure out. So 10 is because from 0 till 9 I have 10 digits. Why minus 1? Because one of the digits I have already used here, and no repetition is allowed. See, no two digits are the same, so I'll have only 9 ways here. So again here I will write 9 ways. Similarly for the 10th place, out of these 10 digits, now 2 digits have been utilized, one in the thousands place and the other one in the hundreds place. So I have 10 minus 2 is equal to 8 ways. And similarly for the units place, I will have 7 ways. So what is my answer here? Total number of 4-digit numbers such that no two digits are same. 9 into 9 into 8 into 7. You may calculate this and this will be your answer. Okay, let's solve the second question. I'll just change the ink color here. Find the total number of 5-digit even numbers that can be formed. So let's take the second question here. I need a 5-digit number, so I'll make 5 dashes here. Now what are even numbers? Even numbers are the numbers where in this units place I have a multiple of 2. So units place I have a multiple of 2. So I can have 0, I can have 2, I can have 4, I can have 6, or I can have 8. Okay, so this units place is what that matters. So in this units place, in how many ways can I fill this units place? 5. I can have 0, 2, 4, 6 and 8. Let's move to the 10,000s place now. This can be filled up in how many ways? 9 ways, because any digit from 1 till 9. Again remember, 0 cannot be here, because if 0 comes here, it's a 4-digit number. But in the thousands place, this can be filled by 10 ways, because here 0 can also figure out. In the thousands place, 0 can figure out. Again here I'll have 10 ways, and here I will have 10 ways. So what are the total number of digits that can be formed? 9 into 10 into 10 into 10 into 5, which is nothing but 45,000. Okay, so I hope this is clear. So let's look at this third question here. Find the total number of 5-digit numbers in which 3 appears exactly twice. To solve these kind of questions, we always form cases. So case 1 here, and let me write case 2 here. So case 1, I'm assuming that in this 5-digit number 3 appears here in the first place. Now this is the 10,000s place. Since I've already written 3 here, this place can only be filled in one way, which is 3. Now since 3 has to occur 2 times, out of these 4 places, there is one more place where 3 will come. Just one more place. So in how many ways can I choose the space where 3 will occur? In 4C1 ways, or in other words 4 ways, because it can occur in any of these 4 places. So let's say that I have chosen this space, and this space has already been booked now with another 3. Okay, so till now I have chosen the first place in one way and have chosen another place in 4C1 ways. Now I have 3 spaces left. In this question I have this thousands place,
and I have this hundreds place and the units place. Now in how many ways can this thousands place be filled? This place, yeah, this can be filled in 9 ways. Why 9? Because I can have any of the digits starting from 0 till 9, but not 3. 3 has to be deleted here, because if 3 occurs here, then 3 will not occur twice, but it will come 3 times. But the question requires us that it occurs only 2 times. So this place can be filled in 9 ways. Similarly, the hundreds place can also be filled in 9 ways. The same logic as here. And the units place can also be filled in 9 ways. So what is my answer here for case 1? I will have 4c1 into 9 into 9 into 9. So this is my answer for case 1. But this is not the final answer, because I will need to add the number of ways I can write in case 2. Now what if 3 does not occur at this first place? In this case, I am assuming that 3 will not occur at the starting of the number. So this is definitely not 3. So in how many ways can this place be filled now? I have 0, 1 and up till 9. I cannot have 0 here, because then it will be a 4-digit number, and also I cannot have 3 here, because this is the assumption for this case too, that 3 does not occur at the 10,000s place. So in how many ways can I fill this place? I can fill this in 8 ways. Now out of these 4 places, 3 has to occur in 2 of the places, because 3 occurs twice. So in how many ways can I choose 2 places out of these 4? In 4c2 ways. So in 4c2, that is nothing but 6 ways I have chosen. There are 6 combinations of 2 places. Now let's assume that 3 occurs here and 3 occurs here. This will be one of these 6 ways. So now I've already booked 3 positions: the first place, the second place and the third place. Now I just have to fill in the remaining 2 positions, that is the units place and the tens place. Now in how many ways can the tens place be filled? I can have any number from 0 till 9, but definitely not 3, because 3 has already occurred here, and the condition for the question has already been satisfied, that 3 occurs twice. So this place can be filled in how many ways then? 9 ways. 10 minus 1. Similarly, for the units place also, this can be filled in 9 ways. So what is my answer for this case 2? It is 4c2 multiplied by 8, this 8 here, multiplied by 9, multiplied by 9. So this is my answer to the second case. So what is my total answer? My total answer is this plus this will give me the total number of 5-digit numbers, in which 3 appears exactly twice. I hope this is clear. Let's move on. How many numbers are greater than 1000 but less than 10,000 which are divisible by 5? So I'll write 1 here for the first question. Now I need numbers divisible by 5. What is the divisibility rule by 5? That the units place should either be 0 or should be 5. Only these 2 possibilities are there. Now I'll have to form a 4-digit number, because I want greater than 1000 but less than 10,000. So my number range is actually 1001 till 999 and 9. In how many ways can this units place be filled? According to the divisibility rule, there can only be either a 0 or a 5. So this can be filled in just 2 ways. In how many ways can this tenths place be filled? 10 ways, because I can have any number here, 1, 2, 3, 0, 9, any number from 0 till 9 can occur here. So this can be filled in 10 ways. Similarly, this hundreds place can also be filled in 10 ways. Any of the digits can figure out here. Now, in how many ways can this thousands place be filled? We need to be a little careful here. So I have digits from 0, 1 and till 9. I am sure that 0 cannot occur here, because then it will be a 3-digit number. It will not be greater than 1000. Rest any of these digits can come here. There is not a problem. So I will write what here? 9 ways, just eliminating 0. So what are the total number of digits or total number of numbers, 4-digit numbers greater than 1000? 9 into 10 into 10 into 2. Okay, so these are 1800 numbers, but be careful that these 1800 also includes the number 1000, but I want numbers greater than 1000. So what is my final answer? It is 1800 minus 1, which is 17, 9 and 9. Be careful about this. A lot of people make mistake here. Always consider what numbers have you counted. In these 1800 numbers, I have not counted 10,000. Why? Because I only took a 4-digit number and 10,000 is a 5-digit number. But I included 1000 here while counting this. Okay. So what is my final answer? It is 1799.
So let's look at the second question here. How many numbers are greater than 1000 but less than 10,000 which are divisible by 5 but no 2 digits are repeated? So in other words, I need a 4-digit number. I'll solve this question using cases. I'll form 3 cases: case 1, case 2 and case 3. In case you're wondering how do I form these cases, this you learn only through practice. So make sure you practice a lot of questions on PNC. Now for a number to be divisible by 5, the units place has to be either 0 or 5. This is the divisibility rule for 5. So if I have a 4-digit number here, case 1, I'll take that the units place is occupied by 0. So I fix this place as 0. Now, if 0 has already been taken up, this tens place can be filled up in 9 ways. Now, why is this 9 here? Because out of a total digits from 0 till 9, 0 has already occurred here and no repetition is allowed. Digits should not be repeated. So I have 10 minus 1, 9 ways here. Similarly, for this hundreds place, I will have 10 minus 2 since a number occurs here and 0 already has occurred here. I can fill this up in 8 ways, and this thousands place can be filled up in 10 minus 3 or 7 ways. So what are the total number of numbers that can be formed? 7 into 8 into 9 into 1, which gives me 504 numbers. Let's look at case 2. In case 2, what I'll do is I'll fix the units place as 5. And I put an extra condition that 0 occurs in this number. So units place has 5 and 0 should occur. I am very sure that 0 cannot occur here in this thousands place, because if 0 occurs here, it would be a 3-digit number, but I need a 4-digit number. So 0 can only occur in one of these two places. So in order to select a place out of these two places, that can be done in 2C1 ways or 2 ways. So any one of these two places will have 0. Let's suppose that 0 occurs here in this hundreds place, so I write a 0 here. Now this place, the tens place, can be filled up in 10 minus 2 is equal to 8 ways. Now why is this 10 minus 2? Because 5 has already occurred here in the units place and 0 has already occurred here in the hundreds place. So this can be filled up in 8 ways. Similarly, the thousands place can be filled up in 10 minus 3 or 7 ways. Now why is this 7 here? Because 0 has occurred, 5 has occurred and one number comes here. So what are the total number of numbers? 7 into 2 for this 2C1 into 8 into 1 for this 5. So this gives me 112. So 112 numbers or 112 ways. Let's look at case 3. In case 3, the only numbers that are left to be counted are which have 5 in the units place and 0 does not occur. So 0 does not occur. So now I have 3 more places to be filled. This place can be filled up in 10 minus 2 8 ways. Now this 8 is because 5 has already been taken up in this units place and 0 will definitely not occur. So out of a total number of digits 10, 0 till 9, I cannot take 0, and similarly I cannot take this number 5. So only 8 are left since there is no repetition allowed. Similarly, this hundreds place can be filled up in 10 minus 3 7 ways, because 0 cannot occur, 5 cannot occur, and one number which has already been taken up here cannot occur. And this thousands place can be filled up in 10 minus 4 or 6 ways. So I have 6 ways here. So how many numbers are possible? I have 6 multiplied by 7 multiplied by 8 multiplied by 1. This gives me a total of 336 numbers. So what is my final answer? It will be obtained by adding all these numbers. I have 336 numbers for case 3, 112 for case 2, and 504 for case 1. So total of, when you add all of them, you'll get 952 numbers. So this is my answer to the second question here.